I've been struggling these last couple of minutes to join, but nonetheless, we're going to continue our discussion. I'll just kindly ask if one of you could just confirm if you can hear me just fine, and also if you can see my screen. I've just shared my screen.
Yes, we can see and hear you, sir.
Okay, all right. Thank you very much. So yeah, this thing is telling me my internet is unstable here. I have no idea what's going on with the world here. But anyway, on with it. So we're gonna continue our discussion now. Before we start, I just wanted to apologize. Right, but yesterday I don't know what's happening here, but communication appears to, I don't know. I kind of erroneously thought I had reached out to the group, or perhaps I assumed I had communicated the fact that I was going to be away. Um, I have been working from out of town from yesterday and part of today actually, which is the reason why we were unable to have class yesterday, right? And unfortunately, I was helping facilitate the the workshop that was taking place, and so I couldn't even you know uh, take time off here to have class. Otherwise, I probably would have insisted that we have a class. And so what I what I did was I reached out to Miss Mtonga here, right, to propose, I suppose, to propose that we have we have a makeup class or something. And and in fact, what I did was I said we have class. I said I was available. Um, in fact, when I sent her the email yesterday, I told her I would be available either at 19 hours yesterday, or anytime between 14 hours and 17 hours on Saturday. Um, and her response was that now sometimes it's important to speak uh, to speak with evidence here. You know what I'm saying. So what Violet said was that Saturday apparently was fine with the class. Right now, she didn't really indicate what time exactly between 14 and 17. If you want, actually, we can have that would be nice. Tell me, we can have class between 14 and 17. That would be like a 3 hour long class. Maybe we could have. It would be a nice way of us bonding. We haven't bonded, right, since we started interacting in February. So it's a 3 hour long class, I guess, or something like that. But anyway, so if that's the case, I'm going to choose, because you're available, I'm going to choose 15 hours, just because uh, actually, I'm going to choose 14 hours. I normally have a meeting at 13, but tomorrow I think we can skip the meeting I normally have with my research students here. So just take note, the class we were supposed to have yesterday, has been rescheduled to take place tomorrow at 14 hours. That would be fun. In fact, what you know, it's the same time we're supposed to have it on Thursday, you know. So as fate would have it here, it's almost like the stars have aligned here. So I've just made this change. Please take note um, that we have a class tomorrow at 14 hours. I just say hello, everyone. Uh, uh, Please note that our Thursday, that's August 7th, 2025, class has been rescheduled to August 9th, 2025 at 14 hours. Uh, this interaction shall be virtual or something like that. Okay, so please take note. Um, so That's resolved. All right. So on with it. You know, we've started a very interesting discussion, and I think I want to say it's interesting because many a times, if you bump into people that build software, you know, for a living, or people that have had the chance to build software, what you begin to realize is that very few of them will actually get to a stage where they're creating detailed design artifacts. I mean, sure, they'll employ certain types of, UML artifacts, like your use cases and perhaps your sequence diagrams and stuff. In some instances, maybe activity diagrams, right, to showcase the dynamic view of the system that they're building. In essence, trying to showcase the flow of data, for instance, through the system by focusing on a particular feature. Usually, it's a feature that is least understood, right? Um, uh, but it turns out that a lot of people will not really come up with detailed, design artifacts. They only go as far as including these quote unquote popular UML artifacts. So your use case diagrams and your sequence diagrams. That's it. And usually they'll create those things because they want to insert them in the software requirement specification document, SRS document. But this is me saying that it turns out that this is actually important, right? These artifacts are important. They help you really grasp the intricate details of, how exactly you should build this system. Okay, so today we start our discussion of structural models, right? A reminder here that we said our discussion for module number 6, which is system design using the unified modeling language, is going to focus on us discussing some of the widely used UML artifacts. In particular, what we are striving to do is to ensure that there's a discussion of at least one UML artifact that falls within the broad categories of these groupings, right? As specified in the object management group's UML specification. In our case, it's version 5, version 2.5.1, right? So we had a discussion of interaction models, which is why we're discussing use case diagrams. And today we want to discuss at least some models that fall under the broader confines of so-called structural models, right? And really, we're going to be discussing class diagrams. I thought it was really sad when I asked if you've been introduced to class diagrams. I thought it was really sad that you said you did not have a discussion of class diagrams when you were being introduced to programming using the Java programming language in 2010. But in essence, your so-called structural models um, will help you display the organization of the system, typically in terms of, let's say, constituent components that will make up the system. But not only that, right? So they'll showcase organization of components that make up the system and their associated relationships. Okay. And usually these models may be static, right? Um, Static in that they will primarily show the structure of the system design. However, there are instances where they may be dynamic, right? In which case they'll showcase the organization of the system when the program is being executed or when the system is being executed. You typically create these models when you're discussing when you're discussing and designing the system architecture. Okay. Um, so rarely the case that you'd use these models when you're just say eliciting requirements, if that makes sense, right? But when you're actually busy with the design process. So this is one of those classic design artifacts, right? However, there are certain types of structural models, like your class diagrams, which may be incorporated into a software requirement specification document. But at the time they're being incorporated in the software requirement specification document, um, it's okay. It may be okay for them to be incomplete. And you soon see what I mean by incomplete here. If I pull out the Zema SRS document, if you remember, uh, if I pull out the Zema SRS document, you remember that in the analysis models annex section of the document, somewhere towards the end of this 80-page document, was what I introduced as a class diagram, right? I briefly mentioned or introduced this as a class diagram, and I'm not really sure if I highlighted the fact that this was incomplete. So at this point, right, because this thing is being included um, in the SRS document, we don't really care so much that, for instance, the Zema Directorate class has attributes missing, it has operations missing, right? Because um, the reason why this thing was added in here is to help with elicitation, or to help better explain the requirements that were included in this document. Okay, so but ideally, in an ideal case, structural models such as your class diagrams will typically be created as part of the process of coming up with a system architecture for the system. Now, here's the thing, and I do apologize that I'm going to take you guys back to Wikipedia here. But if I UML, if I check the Wikipedia page for UML, what you begin to notice is that some structural diagrams, like your component diagrams, right? I think I hope we have a discussion of component diagrams here. But if I scroll down here and look at the hierarchy of if I look at the hierarchy of these diagrams, and I'm looking for this, yeah, observe, if you look at this, if you look at this diagram, begin to notice that your structural diagrams, right, comprise of things like your class diagram, right, your deployment diagram, your composite structure diagram, your package diagram, your profile diagram, your object diagram, and your component diagram. What we are saying is that what we're discussing now are so-called class diagrams. But ideally, you would find yourself creating these type of UML artifacts during the design stage. And if you've been paying attention, it's phase 2 of the SDLC, right? Which is system design. Anyhow, it turns out one of the most widely used structural UML artifacts that falls under the broader confines of structural models is the so-called class diagram. And you create these class diagrams primarily when you're developing a system using an object-oriented programming approach, right? Where you are modeling the system as a series of objects with their associated relationships. So in essence, your class diagram will show the classes in the system and the relationships or the associations that exist amongst these different classes. Um, the idea behind object-oriented programming is simple, right? If you're creating a piece of software, the thinking is that you be more effective at building the software if you view it from the perspective of real-world objects, in essence. So let's say, I just remembered I forgot something important here, but doesn't matter though. Everything is important, even talking now or eating. So if you are building, let's say, a learning management system or a Moodle for the UNZA, the thinking is that you can take the approach where you're gonna, if you take an object-oriented programming approach, you would view this system from the perspective of real-world objects. Now, real-world objects associated, the real-world objects in essence are things, right? Entities. And if you think about a learning management system like Moodle, even if we didn't have Moodle, you'd say, well, the objects that are going to be interacting in this system would be things like students, right? So it would be a student object, lecturer object, course object. There'll be a program object. What else? There'll be a grade object. Maybe there'll be a resource object. A resource in terms of the PDF document, like a lecture resource or something. Maybe you want to have a quiz object, right? An assignment object. In essence, all of these are reward objects, right? Things. You understand? And so the idea here is once you identify the real world objects associated with your system, you iteratively start identifying important attributes and operations associated with these classes or these objects in essence. Like for instance, we know that a student object will comprise of a name, a student ID, right? A student name, a student ID, what else? A student date of birth, a student nationality, if you want, and a whole range of, and in fact, if you want, 1, 2, 3, 4, if you want here, right? For this to make sense, like if you want to say, well, a student also has a student height, height. These are characteristics, right? Or student weight, student height, and stuff. Student hair color or something. What I'm trying to say here is you when you start thinking about a system from the perspective of real objects, an object can have so many different characteristics, but the focus usually is supposed to be on characteristics that are relevant to the system you're building. So for instance, if you're building the Moodle, I don't think it's necessary for you to have the weight of the student or the student next of kin. That's not relevant. It would be relevant if we were building the equivalent of SIS. You understand? Because this is the information that we find in SIS. Right? So you do the same for lecturer. And you say a lecturer has a lecturer name, a lecturer man number, a lecturer maybe qualification, or lecturer department, or lecturer school, because we have instances where a lecturer from a different school may be teaching the course or something like that, or lecturer status, not lecturer, lecturer, lecturer status. Are they full-time or part-time or something? You understand this? These are all characteristics. Now, at some point here, you'd have, after you identify characteristics, and I'll talk more about this. Ellipse is here, it's supposed to be 3, not 4. You'd start talking about things like operations, right? So you'd have something like, for a lecturer, it's upload assignment. This would be an operation, right? Update grade book. This is like an operation. For a student, it would be check grade book. You understand? And the thinking, right? The proponents of object-oriented programming will always hint at the fact that it's a lot easier to think about a system from the perspective of real-world objects, because these are things that are intuitive. You don't really have to be an expert for you to come up with an outline, right, of the series of operations that a lecturer is going to be performing, or the characteristics associated with the lecturer. Now, granted, I mean, if you're not a domain expert, maybe you may have a bit of difficulties, but it turns out that as you're interacting with clients, for instance, because you'd elicit this information, right? As you're interacting with the clients, it will be a lot easier for you to elicit information as it relates to the operations and the characteristics, right? So in essence, what we are calling class diagrams, again, will showcase the classes. So these things like lecturer, student, course, program. Yeah, but what's that? Grade, quiz, assignment, these are classes and their relationships. Now, I haven't showcased the relationships here, but we already know, right? The relationships here. Like if you look at a relationship between a student and the lecturer, from here, you could say lecturer. The relationship here is what? Teachers or lectures students. Now it gets better, right? The relationships will typically have so-called multiplicities associated with them. So to say maybe one lecturer teaches many students, if that makes sense. That's the kind of relationship that would exist. A student enrolls into many courses, right? So these are the things that we're calling relationships. And really, a relationship based on the relationship name can go either way, right? It's like courses are associated with many students or something like that, but that's okay also. Now, An object class can ideally be thought of as a general definition of one kind of system object, in essence. That's what we're saying. And the idea, by the way, of object-oriented programming, and I know you were lying when you said you didn't discuss this. I know it. I know you. The idea behind the class is you use it as a blueprint they told us, right? So if you're saying you have a student class, if you remember that, when you model, you come up with a model, say a system that's going to have a student class and a lecturer class. You know that at some point you have something like public class, student, right? And then you have private string. I don't know about this here, but private string student name, no default value. Private int. They told us, Miss Goma was like, no, the student ID, speaking like an expert, a student ID must be an int, not a string. Okay, that's fine. But that was on databases. Student, a private int, student ID, right? And then somewhere here you have your methods, is it? You know, a public set, public void set student name or something like that, I guess. String student, dude, student name. Then you'd say this dot student name is equal to student name or something like that. And then you'd have something like public string get student name. Programming, I think I've always thought is like there's nothing like it. I've always thought is like riding a bicycle. You never forget. I don't know, 1, 2, 3, 4. This would be like return this dot get student name or something like that, right? Now here's the thing. What they told us was that a class is a blueprint, right? So it can be used to create different instantiations of that type. So for instance, I don't know how many people are here. I can create a, this is the thing here, construct. I don't even have a constructor here, but I could create a constructor. So, but the idea is I would create something like student, right? Student, assuming there's a constructor, is it? Yeah. I can create a student. I'll call this Muna is equal to new student. And then in here, depending on what sort of constructor I have in my class, I could say this is going to have the first argument is going to be the name, right? Muna. And then the ID 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? I guess this would be enough. I think, yeah, I think so. This would be enough. I'll create an instance of Muna of type class. I can then create another instance of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Another instance of Taonga, for instance, like this. And I'll call this Taonga or some Taonga, like this. And the idea here is using these. So I'm using this blueprint to create instances of this blueprint, but the way they behave and the characteristics associated with these objects are going to be different. And so using this, then I'll do things like Muna dot get student name, right? And if I get student name, this thing is going to return this or something. Now, that's besides the point here. What we are saying is that an object class can be thought of as a general definition of a kind of a system object. This is just a general definition. This is the reason why they call it a blueprint, right? You can use it to manufacture things of that type, ideally. And then we are saying that an association is a link between the various classes that you may have. And it typically indicates some kind of relationship between these classes. A lecturer teaches many students. A lecturer is responsible for many courses. A course has many lecturers, right? Can have many lecturers. There are certain courses like EDU 1020, for instance. Mr. Marimu, Mr. Kaira, for instance, right? Now, so in models during the early stages of the software engineering process, objects will represent something in the real world, usually, right? Such as a patient, a prescription, doctor. And this depends on the it depends on the type of problem you're working on. And usually, it's a you can really get really far if you view the system from the perspective of real world objects. I am not sure if that's I am biased towards that because my initial training, um, insofar as computing is concerned or programming is concerned, started with object-oriented programming. My very first computer program, the first time I saw somebody write computer program, it was in Java, right? And I think I took a total of like 3 different courses, all to do with programming, right? In Java, we had the introduction programming. Oh, two, and then advanced. No, three: introduction programming, object-oriented programming, and then advanced object-oriented programming. You know, so I don't know if I was brainwashed. It's crazy, this thing here. Sometimes when somebody tells you something over and over again, you start believing, right? I think for the most part, I don't know. But anyway, so this is what we're saying here, right? If you look at this completely different example, we're saying that we have 2 classes, a patient class and a patient record class, right? Usually, if you look at this patient and patient record, it's clear that these 2 classes are associated with some sort of system that's going to be used to keep track of patient records or something, or to process patients, right? And what we see here is the fact that a patient is linked to a patient record, in that a patient one patient, if you see this multiplicity, one has one record. And this makes sense. If you go to Unza clinic, there's something wrong here if we find 2 records for Miss Mbozi. If she's been to, somebody was sick recently, if we find 2 records for Miss Mbozi here, there's a problem at Unza clinic. Ideally, the way a health facility works is you have 1 record for each patient, unless if that patient goes there with 2 NRC numbers or some crazy thing, or 2 student IDs or something like that. Now, ultimately, right, when you're creating this so-called class diagram, similar to a use case diagram, it's usually created in such a way that it showcases the broad range of classes associated with the system you're building. And if you look at this example, the hypothetical example from your recommended text, which is prescribed text, which is the EN Somerville introductions, or is it software engineering text, we see that we have 8 classes. And all of these 8 classes are linked to each other somehow, right? A patient, many patients can be diagnosed with many conditions, right? This is one asterisk, one to many, the asterisk. I'll talk more about this. What else? Many patients, one or many patients, are referred by a general practitioner. One to many patients, or I don't know what this attends patient. Okay, one or many patients attend one or many consultations. When you are sick, you are feeling unwell. I was feeling unwell the other time. It was crazy. I went there. I went for, well, it was 1 consultation, but assuming I was told to go back, it would be another consultation. So there'll be like a number of consultations, you know. So what we are saying here is a class diagram will comprise of classes: condition, consultant, patient, general practitioner, consultation, hospital doctor, treatment, medication. And each of these classes will be linked to other classes using what we're calling relationships. A relationship will typically have a name, this name. A relationship, or the classes, will also be associated with so-called multiplicities. In essence, you're trying to hint at how many instances of that class can be associated with the other class that is linked to. It could be exactly 1, like for only 1 consultant, 1 here, right? I referred to a patient, or a patient is referred to many patients, 1 to many, the asterisk is many, can be referred to 1 consultant, if that makes sense. Now, here's the thing. What I'm showcasing here, what we're showcasing here, is an incomplete representation of your typical class diagram. Ideally, what we are calling a class, like condition or consultant or general practitioner, medication, treatment, hospital doctor, consultation, or patient, is only comprehensive if you have a broad spectrum of important aspects or elements included. And this is what we are seeing right on the right here. We see that a class like consultation would typically be associated with, well, three main things here: the name itself, which is consultation, the attributes or characteristics in the middle compartment, and the operations in the last compartment, or the methods. So what we are saying is that in a complete class diagram, a typical class is represented by a rectangle to the right. The rectangle comprises of the class name, the very first compartment here at the top, consultation, attributes of the class. The middle compartment comprises of attributes here. So the attributes for consultation are doctors, date, time, clinic, reason, medication prescribed, treatment prescribed, voice notes, transcripts, and a whole slew of other attributes. In addition to the class name and the attributes of the characteristics, a class will also comprise of methods, operations: new, prescribe, record notes, transcribe. Now, I mean, we know what the class name is, right? It's the name of the real world object that we are modeling in our system. Your attributes are essentially characteristics or features that will help contextualize the class. It's like collectively, they will help describe this class that you're using to model your system. For us to describe a student, we have got to specify their name, their student ID, at the very least. Probably even their name, their student ID, their program, and all sorts of other things. Please don't say hair and hair length here. Yeah, students don't surprise me, to be honest. But then, so your attributes are just characteristics that help contextualize the class. And then your methods are actions. This is why they're called operations, right? Actions that a class can perform. It's like if you created this system that has the class general practitioner. What can a general practitioner do? A general practitioner can recommend a scan to be performed. They can prescribe medication. They're talking to you. What's wrong, Mr. Lighton? They test you and stuff. They say, no, we are giving you antibiotics. That prescription you take to the pharmacy. So they are prescribing medication. Right? So your methods are actions that the class can perform. And what we see here is in object-oriented analysis and design, OOAD, or OOP, object-oriented programming, it's quite common really to implement helper methods for class attributes. These are the things that were introduced to you as get and setter methods. So this notion that if you define a set of attributes like doctors, date, time, clinic, reason, medication prescribed, treatment prescribed, voice notes, and transcript, there could be certain operations that you may want to perform to these attributes. And so what you do is you typically define public methods to manipulate these attributes or to gain access to these attributes. They introduced you to this notion of information hiding, right? They told us class variables must be private. You don't make this public. Now, because they are private, the visibility here is only going to be restricted to the class itself. So if there's another class called course which needs to access the attribute, the name for Muna, for us to within the class course, we want to access Muna.get student name. We want to get Muna's name. We can't just say student. Student name or something. We can't just say Muna. We wouldn't be able to do from within You guys maybe listening. So if let's say we have public class course, and then we have private course name, and then we have in here we have public an array um, enrolled. I'm just making this up. Enrolled students. Let's say we have a method that just prints out an array comprising of all students enrolled in a particular course. You know what, guys? I'm going to say private course code, something like this. In here, I want to say something like course code. In here, I want to say I want to say, in here, maybe I would probably have some array or something like that here. Okay, let's just say we have an array, right? We have an array called, I'm making things up here, but enrolled students. I'll say list of students or something like this. I'm forgetting the type here. I've done Python a lot here. Such that, and then this is a string of type array. So let's say we want to, in here, right, enrolled students, add enrolled student or something like this. And then in here, we want to do something like list of students dot add, and then want to add the names of students. In here, what we could do is we could say the object Muna dot, we say Muna dot because the student class has an attribute called, okay, student ID though. It has an attribute called student ID. I would say Muna, I could say Muna dot student ID. But the thing here is that this student ID is not visible within the course class. Why? Because putatively, by convention, there's this recommendation that you hide information. So the only way you'd be able to gain access to Muna here is you would have to create an instance of Muna, right? To say student. Assuming you've already created it here, you'd have to say Muna dot get student ID. This get student ID is what we are calling a helper function. These set and getter methods, set and get, they're called set and getter methods for setting and for getting. If this is making sense, I don't know. So typically it's common to implement these helper methods, right? Anyhow, now I hope this is making sense. I don't know if I have, let's see if okay, there's another, we provide detailed examples here. There's a walkthrough. We want to talk about these things. Aspects of UML diagram, so it's fine. Wanted to see if there's something I've left out. So we'll discuss in great detail other information we add here, because it turns out that when you're modeling a class in a class diagram, this is incomplete actually. So you'd have to specify things like the visibility, default values where applicable and stuff, right? And you do this using a specific type of syntax, they call it. Now that we know the different elements that comprise a class, right? There's a class name, there's attributes, and there are so-called methods, operations. The question to ask is, what about these relationships we're talking about? Remember, we're saying that your class diagram will comprise of classes, and these classes will be linked together using relationships, right? Well, it turns out that there's a number of different types of relationships. Like, for instance, generalization relationship, right? And you typically use this sort of relationship when you're trying to model some sort of complex aspect of your system, right? And complexity from this perspective is in line with certain types of generic functionalities. Here's an example. We quite all right, we have a student class like this. What you and me know is that we can have a student class, but we can also have an undergraduate student class. We can also have a postgraduate student class. The reason we are doing this is because there are things that are specific to an undergraduate student, things that are specific to a postgraduate student as well. Like, for instance, an undergraduate student does not have to produce a dissertation or a thesis. In fact, this gets better, right? A postgraduate student can be a master's student, can be a PhD student. This is what we are calling, this is what could be a classic example of a complex object types, right? And the thinking behind this is that in as much as an undergraduate student, a postgraduate student, a master's student, and PhD student are different, but they have certain things in common. If you look at the UNZA, whether you are an undergraduate student or you're a postgraduate student, you shall have a name, right? You shall come on. You shall have a name, right? You shall have a student ID, right? You shall have a date of birth. You understand? And so if this is the case, the idea behind generalization is if there are certain things that are common amongst whether you're dealing with an undergraduate student, a postgraduate student, then what we can do is we can factor out that functionality, right? And reduce its complexity. If this is making sense, so that you have something like, well, we have a student class, but the student class can be used to simplify the undergraduate class or postgraduate student class. Furthermore, this gets better. A postgrad class is a generalization of what we know at UNS as a master's student class and PhD or doctoral student. Right? So the idea behind generalization, right, is that this is what I say, rather than learn the detailed characteristics of every entity that we experience, we replace these entities in a more general class. Right? Like if we're building, let's say, a software that is going to be used by kids to teach them the different sort of animals we have. Oh, look, Mr. Frodo is an elephant or something, a hippopotamus or something like that. You can have, rather than having a separate class for, or just having a class, hippopotamus, rhinoceros, elephant, giraffe, what you can do is you can say, because there are certain things that would be common amongst these different animals. Some of them are mammals and something like that, amphibians. You can have a generalized class called animal. And then from animal, you derive these other classes. In fact, generalization is about deriving other things. Right? So you are, in essence, going to be able to infer different members of this class, right? The common characteristics that are associated with the different members of this class. Again, the way that you identify these things is dependent on the problem space you are working on, right? But because you're dealing with real-world objects, it becomes quite intuitive. Actually, it's not as hard as it would be if you are using a completely different technical approach. Okay, so it brings us to this point, right? So when you're modeling systems, it's useful to examine the classes to see if there's scope for generalization. So if you're tasked to build a Moodle, the first thing you do is, analyze all the different classes you've come up with and try and see if you can simplify the complexity that exists, right? Here's the thing. For this, the examples given here, a course, right? There are full courses and half courses. So maybe you may want to have something like full courses. Initially, you come up with a class called course, but then you realize, wait a minute, man, these courses are different at UNZA. There's a full course and there's a half course. So there's a full course and a half course because the credit scores are different, but we know that there are certain things that are common, whether you're dealing with a full course or a half course, like the course code. course code. Course code is common here and here. What else? Course name. Whether it's a half course or full course, it's going to be the same. There could be other certain things that are different though. So what you do is you factor these out and you say these are going to be associated with the course class, and then what we specify in the full course and the half course are things that are specific to these classes. We are simplifying the complexity, I guess. Okay, so in object-oriented languages like the Java, for instance, Perl, C++, yes, I know, PHP, right? Generalization is implemented using class inheritance, right? And these are inbuilt within the language. What did they say in Java? They told us, well, if we were to implement what we have there, we'd have something like public class postgraduate student. But because we've decided to say we are simplifying the complexity of the student class here, we would say here, they told us, what do we do? Extends student. This is an inbuilt feature within the Java programming language. When you do this, you are telling the Java programming language to say you are inheriting characteristics and behaviors of the class student. If you remember this, I don't know about how much of this you remember here, right? But this is why when Mr. Mbeo was teaching you programming, he said when you're trying to inherit things from a class, you use the extends keyword, right? Public class postgraduate extends student, and then from here you'll be able to gain access to the behaviors of these things here, of this other class. This is inbuilt. Anyhow, I don't know here. So anyway, in a generalization, the attributes and operations associated with the higher level class, also called the parent class, are also associated with the lower level class, also called the child class. So there's some sort of parent-child relationship or superclass, subclass relationship. Or base class, derived class relationship, if you remember. It's quite intuitive here. But the idea here is that the lower level classes, subclasses, are the ones that inherit attributes and operations to a superclass. So it's not the other way around, right? You cannot assume that the student class will be able to inherit the things in the postgraduate class. It's like what happens to us, right? We inherit from our parents. This is why, by the way, this is also called a parent-child kind of relationship. Parents don't inherit any characteristics from children. You know, I should mention this upfront here. In the Java programming language, what happens to us in real life where they say, oh, the nose is from the father and the eyes is from the mother. We can inherit from two entities, right? Two parents, the mother and the father. But in the Java programming language, they told us, right, that you cannot inherit from multiple classes. What did they say? The diamond problem, right? In Java. You remember this? You remember the diamond problem? You guys should be serious. Can you hear me with live? I don't understand this group of students. Can you hear me? Yeah, I don't know about that here. But anyway, so the key thing here is the key thing for the purposes of what we're discussing, we're not really concerned about the implementation specific details, right? Implementation may vary based on the language that you're using. The thing about class diagrams is that you can use them to come up with an implementation in the Java programming language, in PHP, in Python, in C++. You understand? The modeling itself is language agnostic. And the way that you represent generalization is by using a directed arrow, right? Which is not filled out. It's hollowed out, if you notice here. In this particular case, what we are saying is that hospital doctor inherits from doctor. General practitioner inherits from doctor. A consultant inherits from hospital doctor. A team doctor inherits from hospital doctor. A trainee doctor inherits from team doctor. A qualified doctor inherits from team doctor. Now, here's the thing. If a consultant inherits from hospital doctor, then it goes without saying that implicitly the consultant inherits from doctor. So whatever characteristics are associated with doctor, they also be linked to a consultant. Trainee inherits from team doctor, meaning that implicitly trainee inherits from hospital doctor because team doctor inherits from hospital doctor. There's a cascade effect. Okay? If that makes sense. Now, ultimately, if you are to put everything together, when we're trying to specify a generalization relationship that exists between two different classes, holistically, this is what you see. Each class will have attributes and methods or operations, and then you're using this directed arrow here to specify that there's a generalization relationship. Now, the way this is indicated here, it's not like every time you are modeling a class diagram, you're creating a class diagram, then you have to have these two solid lines here. In some instances, you may just have two classes, right? Doctor and hospital doctor. So in this particular case, you just have like a directed arrow originating from the subclass, terminating to the parent class. Do you understand this, ladies and gentlemen? Listen, this is 1901. I'm going to suggest that we pause. Today was a busy day for me. But I want to pause here. When we meet tomorrow at 14 hours, 14 hours, we shall continue our discussion, and then we'll look at other types of relationships. We'll look at aggregation, right? Very interesting. We shall look at composition, and then we'll look at how we put everything together, right? And then we'll have like a walkthrough, so that we have an idea of how to create a comprehensive class diagram like this. Before we maybe walk you through how you use a computer-aided software engineering tool to create a very nice looking class diagram or something. And then if we have time, we shall immediately proceed and look at interaction diagrams, more interaction diagrams here. This is like sequence diagrams. I'm going to pause here and ask if there are questions. If there are no questions, ladies and gentlemen, this is the part where we say good night. We'll see you when you see me, which is tomorrow at 14 hours. Bye.